All right, Algebra 2, we're going to work this week on how do you condense and expand logarithms so that next week we can apply them and we can solve some equations. So if you think of the laws of exponents, when you have an exponent to an exponent, we multiply them. And the same property happens with logarithms. If you have an exponent to an exponent, if you need to expand it, then it would come to the front and it would look like this. So this left side is the condensed form, and this right side, when we move the two to the front, this is the expanding form. So what you need to know is that when you have an exponent, it can move and become multiplication. In the laws of exponents, when you are multiplying variables, you add the exponents. And so in logarithms, when you multiply, if you wanted to expand it, you would take them and break them apart and you would add them. So this left side is what it looks like when it is condensed, and this right side is what it looks like in expanded form. And so you need to know that multiply and addition go together. And then finally, in exponents, when you divide variables, you subtract the exponents. So similarly, in logarithms, when they're being divided, if we want to expand and break them apart, we subtract them. So this is what it would look like in the condensed form, and this is what it looks like in the expand form. So you need to know that divide and subtract go together. So we're going to take this logarithm and we are going to expand it. So the first thing that I would do is I would see what is going on. So this is 5 times x squared times y. So you have basically two multiplication properties there. Those two multiplied, we're going to break apart by addition. So this is going to become log base 7 of 5 plus log base 7 of x squared plus log base 7 of y. In the fully expanded part, we do not have any exponents. So the last step is that you're going to have to take this exponent, and we're going to have to use this, it's technically called the power property, and we're going to have to move it to the front and multiply it. So this becomes log base 7 of 5 plus 2 times log base 7 of x plus log base 7 of y. And this is how you expand logarithms when you have terms being multiplied together. All right, so we have log base 4 of 4 to the third power. So the first thing I'm going to do is I'm going to move my exponent. So the exponent moves and it becomes multiplication. So I have 3 times log base 4 of 4. Log base 4 of 4. We did this once back in a prior section, and this will simplify to 1. You need to always simplify when you can. So this becomes 3 times 1, which this whole expression simplifies to 3. On part C, I have a lot of things going on. First thing that I would do is I would break this up and I would deal with my divide first. And you need to remember that when you see division, that breaks apart using subtraction. So I have log base 4 of 7x to the third minus log base 4 of y to the second. All right, so now we have 7 times y to the third. So I'm going to have to break up this multiplication here by adding them together. And then on the second expression, I see an exponent. I'm going to have to use the power property, and it moves to the front and becomes multiplication. So I have log base 4 of 7 plus log base 4 of x to the third minus 2 log base 4 of y. And then in fully expanded, you're not allowed to have any exponents. So now this exponent of a 3, we're going to move it to the front, and then we should be done. Log base 4 of 7 plus 3 log base 4 of x minus 2 log base 4 of y. And that is my good final answer, fully expanded. Letter D would work the same. I would break it apart using subtraction, and I remember why I'm doing number 4 now. Okay, so first thing that I would do is break it apart. Anytime you see divide, I would probably undo that first. So I have log base 8 of 9a to the 4th minus log base 8 of bc squared. All right, so they each have multiplication. So I'm going to have to break that part up using addition, and I'm going to have to break up my b and c that are being multiplied by addition there as well. So I have log base 8 of 9 plus log base 8 of a to the 4th minus log base 8 of b. All right, so as soon as I break this up, since this entire bc squared was in the denominator, I'm going to put parentheses around this because if you're going to have two terms here and they're both in the denominator, it is safest if you just use parentheses. And so plus log base 8 of c squared. So anytime that you have two terms in the denominator, you're going to want to use parentheses. So I have subtraction, where it separates the numerator from the denominator, and then if you have multiple terms in the denominator, those denominator terms are being multiplied together, so that's why I have addition right there, but the whole thing needs to be in parentheses. And then it looks like I have an exponent there that needs to move, and an exponent there that needs to move. So my final answer is a long one. Log base 8 of 9 plus 4 log base 8 of a minus, I'm going to go to the second line, and then I'm going to have some parentheses, log base 8 of b plus 2 log base 8 of c. So that one we probably need to put a star around, and that was a pretty advanced problem. I think the condensed are much, much easier than expanding. So now we're going to take something that is fully expanded, and we're going to work our way backwards. So I see a plus sign here. So I'm going to, no, I'm not. I see a 3 out in front. So the first thing that you're going to do anytime you see multiply, I would probably move that back to the exponent position. So I'm going to take the 3 and I'm going to move it back here. So that gives me log 5, guess I have a base 10, plus log of x to the third minus, and I guess I should take care of everything at once. I see another 4 out in front that shows multiply. I'm going to move that back to the exponent position. Minus log of y to the fourth. These first two that are being added together, so anytime you have add, we're going to put these together with multiplication. And then I have subtraction there. And so anytime you see subtract, that becomes division. So that's going to be in the denominator. So my good final answer is log 5x to the third divided by y to the fourth. So what I want you to notice, when we fully condense something, as we move it all together, it's just these end parts that end up over here. And please notice that I wrote the word log only one time. All right, so step number 1, I generally take care of my exponent. So anytime you see a number out in front of the log, we're going to move it back to your exponent position. So I have log base 2 of x to the fifth minus log base 2 of y to the second. So this y to the fifth and this y to the second, those are the two things that are going to end up together. And then I see subtraction. And when I condense, I need to use division. D-I-V-I-D-E. Okay, so my good final answer, log base 2, that I'm going to only write one time, x to the fifth divided by y to the second. All right, I have addition going on here, and I don't have any numbers out in front of my log, so the addition part means that I'm going to multiply those together, and the subtraction part means that I'm going to divide, and that's going to show up in the denominator. So I have log base 2 of 5x over 10. And that's what I can live with today. Looks good. I'm going to run out of time. I'm going to hit the pause button, and we're going to continue the back side in a second on the next video.